Hello, everyone. Welcome back to the AAS YouTube channel, and this is part of the AAS Education Series, and I'm super happy to have Tom Hockey with us today. Hi, Tom.
Hi, Frank. I've made it back to the big time. AAS Ed Blog.
I don't know, big time, but okay. Yeah, my agent will be contacting your agent soon for that, and we'll do lunch or something like to that effect. I don't know. Very good. And Tom, you are in Iowa, correct? Yes.
I am one of the seemingly few states that will not experience an eclipse
Ah,
this next 12 months.
speaking of eclipses, let's take a look at where those eclipses are coming from. Bang. There we go.
Yeah, I thought that astronomy educators might spend a little bit more time on eclipses this particular year coming up, of course, because of the coincidence of two central eclipses visible in the United States in one year. That doesn't happen too terribly often. Of course, I'm talking about the annular eclipse of October 14th, which isn't too far away, and then next year the total solar eclipse, the big one,
Yep.
of 8 April.
I am planning on being just outside of Austin. I should be pretty close to center line, like right around in here is where I should be.
That's great. Draw a tangent from Cedar Falls, Iowa to the eclipse path. I'll talk about that in a moment.
Okay.
And that's where I and my students will be setting up shop.
Cool. Cedar Falls. Cedar Rapids. Boop, 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 boop.
One has to zoom in quite a ways to find.
Well, I think the map
University of Northern Iowa. This is true.
Yeah, the map is fixed. It doesn't add cities as you go.
The eclipse maddeningly just both of them just miss the state of Iowa.
Great state of Iowa. Okay.
As do many people who confuse it with Ohio and Idaho.
Yeah, but I bet there will be people traveling to go to one or both eclipses.
Yes, I hope to be one.
Cool. Very good. And I think you have some eclipse demos, yes?
Well, yeah. To that end, first of all, I find that before you tell students what an eclipse is, you kind of got to tell them what it isn't.
Okay.
It's what I call the primary school teacher effect. My students tend to remember what that life coach in early years or said, or they thought this particular teach said, and that eclipses have something to do phases of the moon, which are not rare, have something to do with casting shadows, which they do not. And in fact, then that leads to confusion between phases, not rare, to eclipses, which are and which do involve shadows being cast.
Indeed.
So, you know how it is when we get something lodged in our head early on, it's awfully hard to dislodge it. So this demonstration is, of course, a very familiar one. Right. You get a light source out to stand in for the sun. I love these LED lamps. You get 7,500 lumens. Okay. And you only draw 40 watts, so you don't blow your circuit. Anyway, the students themselves sitting in a classroom, very much like this one, are the Earth. And then you have some appropriate sphere to represent the moon. And of course, as you move around the students, you can replicate all the phases of the moon that they have ever seen.
Yes.
But instead of that, why not have the students do it themselves? So I got myself a whole lot of these ball pit balls from children. They're a nice size.
Okay.
And pick them up from, for instance, rhymes with ball, marked, not too terribly expensive. So I tell my students, today we're going to have a ball. Everybody gets one of these, and they can actually do it for themselves, which I think
That's always
helps.
Yeah,
So we leave the lamp on, and then I ask the students to replicate, for instance, which everybody has seen, when you can see half the apparent disk of the moon illuminated in the sky. Everybody's seen that before. The actual names of these phases comes later. So here we go, but catch, they aren't allowed for anything to cast a shadow on the moon at all. Well, that one's actually pretty easy. You just, the sun is still that lamp in the same place. So you stick you're looking at it, you stick your arm out and look at it, and you can see it. A little more difficult is when I ask students to position the moon ball such that they have a hard time seeing it illuminated at all. And with some trial and error, they come up with something like this, where the moon ball is lost in the glare of the sun lamp.
Indeed.
Not covering the sun lamp. No, that would be an eclipse, but it's really not necessary because, of course, the illuminated side, and any sphere is always going to have half an illuminated side, right? But it's the side away from them. We could even do, I asked them to create a full moon. They see the whole disk of the moon, and that takes a little more exercise. You have to turn around, and you have to turn your head here or so. Again, no shadows. Can't let the shadow of your head, the earth, get in the way, but they can do it. So they realize all the phases without any shadows, except, of course, for the self shadow that any object in sunlight is going to have. So once we've got the phases down, we're ready to talk about arguably more interesting eclipses.
Eclipses in line. 5 degrees. Moon.
The thing with eclipses is that you need a perfect lineup. And let me fix the lights here. We won't need them anymore. Between the three objects involved, the sun, and then the moon, and then the earth, for an eclipse of the sun, like we're going to see. Again, I do not claim this is particularly original. What I've got is the plane of the Earth's orbit around the sun. We may have mentioned that that's called the ecliptic. So this is a segment of that plane. I got the sun going here, and I've got the Earth revolving around it. This particular plane segment is the plane of the orbit of the moon around the Earth. They're not the same. No particular reason why they should be. They're tipped one to the other by about 5 degrees. I often end up exaggerating that for demonstration purposes. So this perfect lineup, everything in the same plane, is only going to happen when the two planes intersect. For instance, here, something here is in both planes. My students often have difficulty with what is this? We call it a node. What's there? And the answer is, of course, most of the time, nothing. It's just a point in space. The moon's off doing something else. But occasionally, yes, it happens to be new moon at the same time. Now, here's a new moon. Right, we've got the moon between, lost in the glare of the sun. Hard to see it. Earth, moon, sun.
Yeah.
But just as was the case with the balls.
It's not playing. You get something though. You get something.
If it happens though at a node, you get a whole lot more. Yeah, now and only now. I mean, I could lay my pencil right in there.
There you go.
I mean, you shoot an arrow and you go through the center of the earth and the moon and the sun all at once. The time it takes
7 minutes
to go from new moon to new moon, and the time it takes to go from node, the one coming up through the plane of the ecliptic, to node, the one going down, the one coming up again, are different. So it's like two wheels on a slot machine. They both have to come up strawberries or something. Like that.
There you go.
The conditions of a total solar eclipse to occur. Phases of the moon every month. Total solar eclipses, something a lot less often.
I'm going to take that analogy to Vegas.
Well, then you got more wheels going.
Even more coincidental. Very good. Very nice. Easy to do. Visual.
Students, though,
hands-on.
Have you noticed sometimes they get kind of sick of all this perfect lineup stuff?
Okay.
Always emphasizing that. And there's a good reason for that. Because most of the pictures they have seen in their textbook don't have the correct scale. It's just really hard to get the scale of the sizes of the objects involved and their distances the same in a single picture. So the pictures, it looks like, getting this line up, not that hard. I figure at least once they should see it for real.
In scale. Okay.
So over here, I have a 9-inch Earth globe.
I'm waiting.
Pretty common, maybe second only to 12-inch, but I've had this forever. My father gave this to me many years ago. By choosing that size, it turns out there's a number of objects that can be used that are within 10% or so the correct scale size of the moon. I have a little squishy ball here.
Okay.
With craters, but you wouldn't have to use that. A 2-inch styrofoam ball.
That works.
Tennis ball is pretty close.
Yes.
I've got it stuck in one of these old-fashioned pointy things that you put scraps of paper on your desk. I got it at a yard sale. Wouldn't have to do that.
Cool.
A thin nail through a board would work just fine, or skip the stand and entirely. So we take a moment to ponder, what did students expect? Did they expect the moon to be bigger than that compared to the Earth, or maybe smaller? There's some in both camps.
Yeah.
But now the game we play is this. I'm going to move the moon ball away from the Earth globe.
Okay.
And I'd like them to tell me, maybe right before, when I have it far enough such that it is to the same scale, that if the Earth and moon were really this size, where in the room would the moon be in its orbit around the Earth?
Okay.
So we start out moving it away. And they very quickly guessed that if I come up with the right answer right away, that's not much of a game. So I start
First shot.
moving the moon ball
Okay.
away at my cart.
Okay.
And some brave soul will tell me to stop.
Oh,
They are almost always too short,
sure.
but I thank them for tracking and paying attention and playing the game. And as we get farther out, others call it. They're
Right.
still too short. And I recognize that I keep telling people no, it gets to be a little intimidating. So the shout outs tend to decrease. And I get over here and I often joke they're just waiting for me to head out the door here, maybe not to be seen again. But the right spot is somewhere around here,
Okay.
about 22 and a half feet. Call it, as I would prefer, 7 meters.
There we go.
And I used to refer to the old Apollo program, but now I can say, talk about the future, those Artemis
Yes.
astronauts.
Right. Right.
They have some serious booking here to do. Now, imagine the biggest spotlight. In fact, there is no spotlight big enough across town. 1.7 miles, call it 3 kilometers or so. And it's tipped over horizontally so that it is aimed at this little ball here, which then, of course, casts a shadow, a shadow cone, because it's smaller than the searchlight, the stand-in for the sun. Sure. And that cone reaches the earth in a spot. That's what we mean by exact alignment for an eclipse. It's no joke. Now, as the moon moves in its orbit around the earth during the eclipse, and as the earth rotates, that spot gets turned into a path here, but still very little of the earth. I mean, you know, some of it's over ocean, uninhabited places, very little, few folks get to actually see the total solar eclipse that results. No wonder they say that if you stay home, your odds are roughly like one eclipse every 360 years. So these you usually have to travel to.
You got to go to.
And then I say parenthetically that if the geometry is such that that shadow cone doesn't quite reach the globe, what people down here will see is an annular eclipse, which is exactly the kind of eclipse that's going to be coming up here in rapid calculation, about 4 months.
There you go. Very good. That's awesome. I love that one. I like the visceralness of it. Very good. So people should take some of these ideas, steal them from Tom, steal Tom's ideas.
That's the idea. Of course, all right, understanding the geometry of an eclipse is one thing. Actually picturing it, what you would experience is quite another. What's involved. You know, pictures, that sort of thing help, though. I suspect Frank would agree that you've got to do it yourself live. But we do a crude eclipse here in the classroom, about the best we can do indoors. I pass out to each of the students, believe it or not, a dried pea.
Okay.
Here, roughly spherical, 3/8 of an inch, half a centimeter at most. So all the students have one of these. And my room, like so many classrooms is illuminated by standard size fluorescent fixtures at a
Yep.
standard ceiling height.
Mhm.
So I asked my students to eclipse the light,
Okay.
at least one of their eyes. I'm not talking about widthwise, I'm talking about, or lengthwise, I'm talking about widthwise, actually create an eclipse to make sure they get what we're talking about, that it's the silhouette of the moon covering the outline of the sun. And it's not easy to do.
No.
I have to take my eyeglasses off to
Center
accomplish it.
pretty well. And then
But whoops, the scale again. The
Well,
scale is
yes.
wrong. In
Yes.
fact, it's off by about 10 times. But anything smaller becomes impractical. We'd just be asking for
Jiggle,
people
jiggle,
to
jiggle, jiggle, jiggle.
stick themselves in the
Right.
eye, right?
Right.
With some sand grain or something. It'd be easier to manipulate, in fact, something larger, like a marble. Of course, then the scale is even worse.
Right. But you
And if any get dropped or left behind, they become a trip hazard. Probably mine. You drop one of these, it just crushes. So that's a pretty crude eclipse. But we've already talked about scale, and hey, this isn't going to be exactly the scale. So we get away with it.
Very cool. I like those. You know, you can make split pea soup.
But we can simulate, we can go outside, hold our fingernail in front of the sun, we can do all of that sort of thing.
Yep.
And as anyone who has ever seen a total solar eclipse in particular, it just is nothing compared to the real thing, which is not just a sight to be held, but really a visceral experience of the entire environment around. And so I'm excited because between the annular, which is not going to be as spectacular, but still there aren't too many. It looks like a big ring hanging in the sky, and that's kind of unusual in nature. And the total, upwards of 50 million people in North America are going to have the opportunity to see one or the other.
Look up. Yes, that'll be so cool. And I think these demos are really cool. I think they help a lot in getting some of the points across. So well done. I like it.
Thanks, Frank. We'll be doing the exact same thing when we start up this this fall. And while we have no immediate plans to go observe the annular eclipse, which is farther away from us, it's a treat for the folks out west in the Rocky Mountains. Still, if any of my students ended up playing hooky about mid-October, I wouldn't blame them.
Okay. Very cool. All righty. Thank you so much, Tom, for sharing your demos. Go ahead and grab those ideas, run it with it yourself, people. It's great. And I hope this made your astronomy day and your astronomy education day just a little bit better. And we will see you on the next one. Bye-bye.